Hey, welcome to the team. I'm so glad you're here. Before you dive into the code base, I want to give you a quick rundown of the absolute essentials, the tools you'll be using pretty much every single day. Think of this as your starter toolkit for handling data in Python. We're just going to cover the big three: lists, tuples, and dictionaries. Ready? Let's get into it.
All right, so here's my first pro tip for you. The secret to writing really good code isn't about memorizing a bunch of super complex algorithms. Not at first, anyway. It's about mastering how you store and organize your data. If you get that part right, your code just naturally becomes cleaner, faster, and way easier for everyone, including you, to understand. And it all starts with something called data structures.
So what on earth is a data structure? It's actually a pretty simple idea. It's just a container for grouping related pieces of information together. Instead of having 10 different variables for 10 different test scores, you can just put them all into one neat, organized package. It's a fundamental building block of, well, everything.
Okay, tool number one in your new toolkit, the Python list. I like to call it your flexible friend, and for a good reason. Its main feature, its whole purpose in life, is that you can change it whenever you want. You can add new things, get rid of old things, shuffle things around, you get the idea.
Okay, so let's look at some code. Don't worry about the Arabic text here. The concept is exactly the same everywhere. See this line that defines a list called grades? The most important thing to notice are those square brackets. That's the symbol for a list in Python. Inside, you just have a bunch of items. In this case, numbers separated by commas. Super simple. This could be anything: a to-do list, a list of usernames, prices, you name it.
And here's that flexibility I was talking about. We can just tack a new grade onto the end using .append. If we made a mistake and need to get rid of a grade, we can just pull it right out with .remove. And with one tiny command, .sort, we can instantly rearrange the whole thing in order. This ability to be changed, the official term is mutable, is what makes lists so powerful.
So, why is this so useful in the real world? Well, once you have all your data in a list, you can easily go through it, item by item, and do something with each one. This code here creates a list of ages. Then it loops through every single age in that list to check if it's over 15 and then counts them up. You are going to be doing this kind of thing all the time.
Okay, so lists are changeable. We've established that. But what happens when you have data that you absolutely positively do not want to change? Maybe not even by accident. Well, that brings us to our second tool. And the main difference is right here on the screen. Lists are changeable, or mutable, but our next tool, the tuple, is unchangeable, or immutable.
All right, tool number two is the tuple. If a list is your flexible friend, think of a tuple as data that's been set in stone. Once you make it, it's locked. You can't change it. And this isn't a limitation, it's a feature. It's all about safety and making your code predictable.
Just take a look at this code. It's a list of the days of the week. That's a perfect example, right? Because we're probably not adding an 8th day of the week anytime soon. And notice the syntax. See the parentheses, the round brackets? That's how you tell Python, hey, this is a tuple. This data is permanent.
Now you might be thinking, why would I ever want data I can't change? And that's a great question. The answer is all about safety. Imagine you're storing something critical like GPS coordinates or the primary colors or calendar dates. You want to be 100% sure that some other part of your program doesn't accidentally mess with that data. A tuple is like a promise that this data will stay constant. Okay, on to our third and final tool for today, and this one is a bit of a game changer. With lists and tuples, you get items by their position, right? The item at index 0, index 1, and so on. Dictionaries are different. With a dictionary, you get data by giving it a custom name, or what we call a key. This slide here really nails the core concept. A dictionary is just a collection of these key value pairs. Honestly, the best analogy is a real dictionary. You have a unique key, which is the word, and it points to its value, the definition. This makes finding the exact piece of information you need incredibly fast and intuitive. And here's what that looks like in actual code. We're creating a dictionary to hold info about a student. The key name points to the value Ali. The key age points to 15. See how much clearer that is? Instead of having to remember that the name is at position 0, you just ask for the name. The code explains itself.
And here's the cool part. Just like lists, dictionaries are flexible. They're mutable. So you can think of it like an editable profile. If the student gets older, we can just update the value for the age key. Or we can add entirely new information that wasn't there before, like adding a city key. You get the flexibility of a list, but with the power of descriptive labels. Okay, we've gone over the 3 core tools. Now for what I think is the most important part of this whole chat, the blueprint. When do you actually use each one? Because making this decision is something you're going to do hundreds of times a day as a developer. This table right here is your cheat sheet. Seriously, you should print this out. It's this simple. If you need an ordered group of things that might change, like a shopping list, use a list. If you have an ordered group of things that must never change, like the months of the year, use a tuple. And if you need to store information and look it up using a unique name, like a phone book, you want a dictionary. That's it. That's the core logic.
So there you have it, your first foundational Python toolkit. Lists, tuples, and dictionaries are the bedrock of almost everything we build. So get comfortable with them, really understand when to use each one, and you'll be writing fantastic code in no time. Welcome aboard again. I can't wait to see what you create.